The beating heart of any Microsoft-based IT department is an Active Directory and domain controller setup. This has served plenty of organizations for many years. However, like everything in life, things change, and the cloud offers many new possibilities for what on-premises environments might look like. It got me thinking, if the new identity security boundary Entra ID now sits in the cloud, that group policy is pushed from Intune, and that Azure Arc manages any servers left on premises, what happens to DNS and DHCP on site? Is it possible to set up a standalone Windows DNS and DHCP server without a domain? To find an answer to this profound question, I left no stone unturned. I travelled far and wide and consulted with many veterans in the field, and in the end, my quest was fulfilled because I was able to create this solution. Now, some may say I'm exaggerating about how I got here, and some may say that a Windows Workgroup solution has always been possible. Yep. Some may say that, but for the rest of you, come with me on this legendary journey and let me show you how to set up internal DNS and DHCP in a Windows Workgroup. It all began with the setup of this Windows 2025 server, whose hostname I set to HQ. I also set the primary DNS suffix to give it a fully qualified domain name of hq.uk and gave it a static IP address of 10.0.1.1. My design has 4 subnets which represent 4 departments, and I decided to do this in order to demonstrate how to use multiple DNS zones. This server will assign IP addresses to each subnet using DHCP scopes, and DNS will create DNS entries using forward and reverse zones. This server is also connected to the 3 other subnets which also have static IP addresses. I pointed the DNS IP to look to the server by assigning the local host address of 127.0.0.1. This is to ensure that they can find host names and IPs on the local network. If you're wondering how they'll find DNS addresses outside of the local network, like the internet, I'll show you once I've installed the DNS role on this server, which essentially installs and enables DNS services. The service will listen for incoming DNS requests on the 4 IP addresses assigned to this server. Here I configured DNS forwarding with Google's public DNS IP addresses, so that if this server is unable to resolve external addresses, it forwards those requests to Google's DNS service. In fact, this is how the internet works. The grey unwashed masses type in host names into their browsers. The requests are passed on to server after server on the internet until one of them is willing to put its hand up and admit to knowing the IP address for the host name being searched for. Of course, we all know that servers don't have hands unless you're watching this 50 years in the future, in which case the servers will have whatever they want. After that bleak glimpse into the future, let's move on quickly and look at the forward zones that I configured for each department. Each zone translates host names to their IP addresses for that particular zone. For this reason, the zone name must match the DNS suffix that is added to clients. More on that later. For now, know that the zone file is the one that stores all entries that are created when host names and IPs are added to DNS Manager. When a client like a Windows 11 PC changes hostname or IP address, this option dynamically updates the DNS entry in the zone file. As the name suggests, reverse lookup zones do what forward zones do, but in the other direction. They translate IP addresses to host names, and so I set up zones for each of the 4 subnets. The network portion of the IP address range is used to identify which clients are to be managed by this zone. Reverse zones also have zone files and dynamically update DNS entries. The DNS configuration was all done, and now I needed to configure DNS's faithful companion, DHCP, which keeps track of all IP addresses it assigns to clients on the network. After installing the DHCP role, Server Manager complained that I hadn't finished the configuration. This is a combination of setting up some security groups and authorizing the server on the domain. I created a standard user to do this named DHCP auth, and once I ran through the wizard, I verified the security groups had been created. Although authorization of the server for the domain isn't required, since there is no domain, Windows will nevertheless nag me every time I look in Server Manager. I then set up 4 DHCP scopes for the 4 subnets, which keeps track of IP addresses leased to clients. DHCP gives out IP addresses to the clients and is the trigger to let the DNS service know that a new entry needs to be created or an existing entry needs to be updated. These options are configured here, and I chose to always update records, including clients that do not request the updates. Another key configuration was to set the router, DNS server, and DNS domain name. When the DHCP server gives an IP address to the client, it also sets the gateway address, the DNS server address, and adds the DNS zone suffix to the hostname. That's why it's so important that any zone names that are set in DNS Manager match the suffix configured here. With this information, the client will get an IP address, will have a route to the internet, will be able to find other clients on its subnet by IP or hostname, and find hostnames on the internet through the DNS forwarder. When setting up a DHCP scope, the name should be something that makes sense. The range is the range of the addresses that should be used by DHCP. In this lab, I leave the first 100 and set a range of 100 addresses. The DHCP scope options is where I configured the router, the DNS suffix, and the DNS server IP that we looked at earlier. On my diagram, you'll notice that I have IP address ranges outside of the DHCP scope, and that's because they are servers, and servers usually require static IP addresses. Now I could create manual DNS entries for the forward and reverse zones, but I don't want to be fiddling around with A records and PTR records. On a DHCP server, IP addresses can be reserved based on the client MAC address, and so I set these reservations for the 2 servers in the HQ subnet. DHCP reservations are useful to ensure the creation and updating of DNS records for static IP addresses. Now that I had everything configured, I spun up several virtual machines so that I could test my handiwork. If all went well, these 2 servers would pick up their reserved addresses. In addition, new DNS entries would appear in the correct forward and reverse zones. The suspense was unbearable as I watched the client starting up. The address leases for the HQ scope showed that the 2 servers had an active reservation, which tells us that they have been assigned addresses by DHCP. Similarly, the IT department clients had also picked up an IP address in the subnet and IP address range that I set in DHCP. IT01 is the Windows 11 client, and its network settings confirm that the correct gateway, DNS server, and primary DNS suffix had been assigned through DHCP. IT02 is the Linux client, and I verified that the DNS suffix and the network settings confirm that the correct settings were assigned through DHCP. At this stage, I was emboldened and ventured to check the remaining clients in the HR and sales departments to verify the DHCP leases. All looked good, so I moved on to check the forward and reverse zones. I could see records in the forward zones, which shows that as the DHCP service assigned IP addresses to clients, it also contacted the DNS service, which in turn created the A records in the correct forward zones. I then checked the reverse zones and saw that the correct PTR records had been created in the correct zones. Going forward, anytime IP addresses or host names change, the DHCP service will know and inform the DNS service, which will dynamically update any A or PTR records. This workgroup setup could be used in organizations that have successfully untethered from Active Directory in favor of Entry ID, or in isolated test or training environments. Whatever the case, IT engineers can use familiar tools to set up this solution. Another successful lab, another video successfully uploaded. Come join me in my success by liking, subscribing and sharing this video, and let me know what you think by leaving your comments. Until next time, live long and prosper.